Hey there, I'm Caesar. Welcome to this Real Python video course on the map function and some general ideas in functional programming. Let's do a quick overview of what you'll learn in the course. We'll start off by getting a basic understanding of the map function through some examples to help you identify when it is that you basically want to map a function at every element of an iterable. You'll get a lot more practice as we go through some examples where we're manipulating iterables of strings with the map function, and you'll even get a chance to write your own version of the Caesar cipher. We'll then take a look at combining the map function with two other important functions in functional programming, and these are the filter function and the reduce function. We'll then take a look at a very useful function that's in the Iterables module called the star map function, which is very similar to the map function, but is tailored to when the iterables that you want to map to are all contained in one iterable. We'll then end the course by going over some Pythonic alternatives to the map function, such as list comprehensions and generator expressions. Even with that being the case, that there are some Pythonic alternatives to the map function, it's good to have a good general understanding of the map function and the filter and reduce functions. Now, before we get into the details about how the map function is implemented in Python, let's go over these basic three ideas that are mapping, filtering, and reducing data. Now, all of these three functions, mapping, filtering, and reducing, are three important ideas in functional programming. In functional programming, programs are constructed by applying and composing functions using a declarative programming paradigm. One of the basic ideas in functional programming is that you write your programs focused more on sort of what it is that you want to do and not so much about the nitty gritty details on how to do it. And you'll see what I mean by this through some of the examples that we do. In functional programming, functions are first class citizens. And what this usually means is that they can be assigned to variables and they can be arguments to functions and they can also be returned by functions. Now, there are three common operations in functional programming, and these are mapping, filtering, and reducing data. Let's do a quick overview of these basic operations. So, first of all, mapping consists of applying a transformation function to an iterable to produce a new iterable. So, the items in the new iterable are produced by calling the transformation function on each item in the original iterable. So, one of the common ways that you're going to be applying the mapping idea is on a list, and you have a list of elements, and you have some function f. And what you want to do is simply create a new list obtained by mapping this function f at each element of this list to produce this transformed list. Now, thanks to the ubiquitous use of iterables and iterators in general in Python, you can apply this mapping idea not just to lists, but to any type of object that can return on demand, one at a time, its elements. The other key operation is the filter one. So, a filter applies a Boolean valued function to an iterable to generate a new, possibly smaller iterable. The items in the original iterable that return a true value are the ones that are kept to produce the new, possibly smaller iterable. So again, if we have a list of elements and we have some function f that returns essentially either true or false, then the elements where f evaluated at each element returns true are the ones that are kept in the new smaller iterable. So in this hypothetical scenario, the values in this list, A0, A1, A3, and A5, all of those return a true value after being applied on by the function f. And so those are the new elements that are kept in this filtered iterable. The last key operation that we'll take a look at in functional programming is a reducer, or sometimes called a fold or an accumulator. Now, a reducer applies a binary operator, so an operator that takes two arguments, and this operator is applied recursively to the elements of the original iterable to produce a single cumulative value. Now, a lot of operations that you've already probably used before, a good example of which is the sum function in Python, is an example of a reducer or what can be considered a reducer. And so the basic idea is that the reduce operation will take this input function f and apply it to the first two elements of this list. And the return value of that operation will be the first positional argument to a call of f, where the second positional argument will be this third element of the list. And recursively, that's how the accumulated value is obtained, producing the value y. We'll see some examples of this. So if you haven't seen this before, at least not talked about it in this way, you'll get a chance to unravel this. All right, well, that was just a quick overview of some of the things that you'll learn in the course. In addition to learning about map and reduce and filter, you'll get a lot more practice with working with iterators in Python. And iterators in Python are everywhere. So if you're kind of new to the idea of iterators, this course will also help to remove some of the mystery behind what iterators are and how to work with them. All right, in the next first lesson, we'll jump right into it and introduce to you the map function. So a basic call to Python's map function takes the following form. It takes two positional arguments. The first one is a function, and the second one is an iterable. And as we saw in the introduction, the idea of using the map function is that you want to evaluate function at every element of the iterable. Now, the first positional argument function can be any Python callable, such as built-in and user-defined functions, classes, methods, and Lambda functions. Map returns an iterator that yields items of the original iterable transformed by function. Now, you can also apply map to functions that take on multiple positional arguments. So, in this call to map, the first positional argument function takes on n positional arguments. And so that means that the iterator returned by map will first take the first element of each iterable and use those as arguments into the function. And so then that would yield the first item returned by the map iterator. And then the next item that's returned or yielded by the iterator is obtained by taking the second element of each of the iterables and evaluating the function, and so on. So it's clear then that the number of iterables n that's passed into the map function has to equal the number of positional arguments accepted by function. Now, one of the nice features with the map function is that the length or the number of values yielded by the iterables that are passed into map, that length doesn't have to be the same for all. And so what's going to happen is that the number of values that are yielded by the iterator that's returned by map is going to equal the number or the smallest number of values that are yielded among the n iterables that are passed to map. So map takes care of all the details about when one of the iterables is exhausted, then the entire iterator returned by map will exhaust. Now you're probably thinking to yourself, the result of map, I can probably just get what I need using a good old fashioned for loop. So why should I use map then? Well, let me give you a few reasons. Using map abstracts the details of iteration, resulting in a more functional approach to programming. Now, I think for you to fully understand this statement, you just have to start using map. Now, I'm not completely advocating that you abandon for loops and list comprehensions, but you'll see that every now and then, your main problem is just to simply map a function to an iterable, and just simply writing that using the map function feels a lot more natural than just having to write out the details of an iteration. Now, a technical reason why you may want to use the map function is that it's written in C and is therefore highly optimized. The internal loop used in the map function can be more efficient than just a regular Python for loop. Another technical reason why you may want to use the map function is that it returns an iterator And so items are processed on demand, resulting in more efficient memory usage. Now, another reason why you may want to use the map function is that when you have multiple iterables, it may be clearer to use the map function than using an equivalent list comprehension and the zip function. And we'll make this comparison in a later lesson so that you can see for yourself whether, in some cases, it is maybe a little bit more readable to use the map function over, say, a list comprehension with the zip function. All right, let's jump into the code. Let's start by taking a look at the help documentation for the map function. So go ahead and type help map. So as we saw, the map function takes in a positional argument func, which is going to be a function, and then a certain number of iterables. And the number of iterables is going to equal the number of positional arguments taken by the function func. The map function is going to return a map object, which is an iterator, and the iterator will yield the values of the function evaluated at the iterables. The iterator returned by the map function will stop when the shortest iterable in the call to the map function is exhausted. All right, let's take a look at some examples. Let's start off with a very simple example just so that you can see how the map function works. So let's create a list of numbers and we'll call the list numbers. And the list is simply just going to contain, say, the numbers from 1 through 5. And what you want to do is simply square each of the numbers in the numbers list and then either save the information in an iterator or maybe just a list. So go ahead and define a function. We'll call it square. And of course, maybe in your application, you have a much more complicated function, but this will do for this simple example. So the function is just going to return x squared or x to the power of 2. And so now let's call map with the square function as the first positional argument and the numbers list as the only iterator because square only takes in one argument. Let's save that in a variable, say sqnums, so square nums. All right, let's take a look at the type of sqnums. So we get map, and as we saw in the help documentation, map returns a map object. Now we can do several things with this sqnums. If we need it for, say, a for loop, then we can just use it as if it's any other iterator. For example, we could just print the values obtained or yielded by this iterator. So let's go ahead and do that. So for num in sqnums, let's just print the value of num. And there we go. We get each of those numbers in the numbers list squared. 1 squared is 1, 2 squared is 4, and so on. All right, let's clear that up. And let's run that exact same for loop again. So for num in square nums, print the value of num. And in this case, nothing happens or nothing's printed. And so if you're not familiar with iterators, an iterator, which is what sqnums is, returns a value on demand. And once all of the values that are yielded by the iterator are exhausted, then nothing else is returned. And internally, there is a stop iteration error that happens in the for loop, and it's taken care of by Python. And so we don't see any type of error message. We just simply see nothing printed to the screen. So that's just something to keep in mind. If you wanted to, say, keep the values of sqnums around, you could, say, create a list based on the sqnums iterator. So let's go ahead and try that just so you can see it. Let's call again sqnums, and we'll call the map function. And at the same time, we'll create a list from the iterator returned by map. And then now sqnums is just a good old fashioned list. And if we run that same for loop again, of course, we get the same print statements. And of course, sqnums is still a good old list. So again, that's just something to keep in mind. the map function returns a iterator object. And if all you need that iterator object is, say, for one for loop, and that's all you need it for, then that's probably what you want to do, especially if it's a iterator that yields a lot of values. You don't want to store a large list in memory if all you're going to need it for is, say, one iteration or one for loop, for example. You're better off creating an iterator, and the map function does that for you. The first positional argument to the map function, it can be any callable. So it could, for example, be, say, a lambda function. Now, the square function that you defined, it's a fairly small function. It only takes one line of code. So that's a pretty good candidate for a lambda function. So we could instead, if we were to go ahead and use a lambda function, we would simply write map and then lambda x, and then just simply return x squared. And we'll use the same iterator, of course. And if you're not familiar with lambda functions, there'll be some more information in the notes that accompany this lesson. So let's run that again. And this is essentially the same thing, except this time we are passing in a lambda function, which is an anonymous function. It has no name. It's just simply defined for the sole purpose of being passed in as an argument to this map call. So if we run that same for loop again, we're going to get the exact same result. There, we're just simply printing the numbers in the sqnums iterator. So to end this lesson, let's do an example where we have some data and it's split up into sort of two lists. And the two lists represent the x and y coordinates of some point in 2D space. And what we want to do is simply compute the distance of the points specified by the x and y lists to the origin. So suppose we have a list, say, of x coordinates. And so this will be negative 3.8, say 2.2, 4.5, and let's just say 0.9. And then we have a list of y coordinates, and this is going to be 1.2, say negative 0.5, and so on. Now, I don't know if you remember this from, say, your math classes in grade school, but if you want to know the length or the distance from a point in 2D space to the origin, the formula is square root of the point x, or the x coordinate squared, plus y squared. And so that is the function that we want to evaluate for each tuple obtained by taking the x and the y coordinates one at a time. So let's go ahead and define this function. We're going to need the square root function from the math module. So we'll say from math, let's import the square root function. And then, you know what? Why don't we just do a lambda function inside the map call? So what we want to do is we want to map the function that takes two positional arguments. These are going to be x and y coordinates. And it's just going to return the square root of the sum of x squared plus y squared. And we're going to get those x and y coordinates from the x coords list and from the y coordinates list. So let's save that in, say, a variable called distances. So we'll add the s there. And that's it. So what's going to happen here is the iterator obtained by the map object will, one at a time, first take an x coordinate and a y coordinate and evaluate this function that takes two positional arguments and will return this value for the first x and the first y. So that'll be the first value yielded by the map iterator, or the iterator returned by map. And then the next value is going to be obtained by taking the second x coordinate and the second y coordinate, evaluating this function, this lambda function, and then yielding that value. So let's just quickly verify this. If we were to go square root of negative 3.8 squared plus 1.2 squared, then we'll get 3.98. If we instead use the second x coordinate and the second y coordinate, then we should be getting from the iterator 2.25. So now let's compare this with the values that are going to be yielded by the distance iterator. So for d, in distances, go ahead and just print these values that are yielded by the distance iterator. And as we saw, the first one, 3.98, the second is 2.25, and the other two are given below. Now, let me show you just one last thing. If, for example, the x coordinates list, let's say actually it only had three x coordinates, and the y coordinates had the same number as before, so in this case, 4, then if we run the exact same code, so distances, and we go ahead and print all of the values that are yielded by the distances iterator, we're only going to get 3, and that's because the iterator returned by map will yield as many values as the shortest iterable that's passed into it. So this is a nice feature of the map function. It's not going to give you an error. It's not going to raise an error. It's just simply going to iterate until it can, and that's going to be determined by which iterable passed into the function has the shortest length. All right, so this ends the basics on the map function. In the next couple of lessons, we're going to be doing some more examples of using the map function. And sort of part of that is just to get you thinking about when you would want to use the map function and if it's something that you want to do. And the more you try it, you'll see that maybe the map function is something that you may want to try every now and then instead of, say, using a for loop or even a list comprehension. We'll talk about that later also in a future lesson.